let's start with today's session. So you guys can see my screen, right? So my name is Huzaifa Arshad and I'm the instructor for SPSS today. So thank you for showing such a uh, good response for the webinar. And today we have people joining from different parts of India, particularly from Surat, Hyderabad, Nilgiris, and then we have people from Delhi, Palanpur, Dehradun, Srinagar, Chennai, Nepal, Afghanistan, and South Africa. So we have some people who are from outside India too. Okay, so uh, I have put the session on recording mode. So in case if there is a network issue, in case there is a network issue for any one of you, you will get the clarifications in the recording mode. Further, you can mail me the your queries regarding the session. I will be clearing your queries via mail or too. Okay, so the topics of discussion for today session is the basics of SPSS, the data handling process, how we basically insert our data in a file, in a SPSS file, and how we process it, like transformation, recoding, and so on. So we'll be going through these processes like recoding, transformation, use of descriptive statistics, and how actually we can use descriptive statistics in SPSS. Now, exploring the assumptions means that um, getting more knowledge about the data, whether the data is normally distributed, whether it is following the bell curve or not, or whether it has homogeneity of mean or not. So exploring the assumptions has to do more with whether we are going for parametric or whether we are going for non-parametric uh, statistics. Okay, so then we have difference between parametric and non-parametric statistics. What are the assumptions and what are different parametric and different non-parametric statistics methods available to us. Further, we have how to choose the right statistical method or how to choose the right statistical test for our research. See, we all are involved in some or other kind of the research, and research for the research to be right, it is very necessary that we understand the data, what type of data we have, whether our assumptions are met or not, what type of statistics we are going to use, and whether the test statistics whichever we are going to use is fit or not fit for the purpose or not. Okay, so we have to keep, whenever we are doing any sort of research, we have to keep in mind some points. The points are what, when, why, and how. So let me clarify what I mean when I say what, when, why, and how of statistics, or what, when, why, and how of SPSS. So basically, what means what statistical method I am going to, what statistical test I am going to use, whether I'm going for a comparison of mean through t-test, or I'm going to analysis of variance, or I'm going for regression analysis, logistic regression, or I'm going for discriminant analysis, cluster analysis, and so on. So by what I mean what type of statistics I am going to use. Then we come to when. The when part of the research is mostly the assumptions, has to do with the assumptions. So the assumptions are, we have to check that for a particular test which we are going to use, whether the assumptions are met or not, whether the assumptions are met or not. Then once the assumptions are met, then only we can go for the statistics. Just people are joining. Okay, whether the assumptions are met or not. See, for different tests, different type of statistical tests, we have different assumptions. For particularly for t-test, we have assumptions like NPC, it follows NPC or not, normal probability curve or not. It has further assumptions of homogeneity of mean. Okay, then for other statistics like regression, we have to check whether there is a multipole linearity or not. If there is a multipole linearity or high correlation between different predictors, then we should not go for regression analysis particularly. So we have to check whether the assumptions of the data are met, or it is fit to use a particular type of statistics on the data, whichever we have selected. So the choice of right statistical method is important. Then coming to why. When we say why is the purpose, what is the purpose for which I am going to use my statistics? Okay, so like for t-test, the purpose is comparison of mean, right? Test then it may be, there are different types of t-test. There is one sample t-test, paired sample t-test. So it may however the idea is same. The whole idea is about comparison of mean. So for correlation, we have to check whether these two variables are associated or not. Similarly with chi-square, the purpose is test of association or goodness of fit. So we have to check what is the purpose, or we have predictive we want to predict something or not. If we have to predict something, then we have to go for the obviously the regression analysis. Okay, there may be other types of methods also, like cluster analysis. Cluster analysis is used when we have to check how the cases are grouping together. So based on the purpose, we choose our statistics. Based on the purpose, we choose what we have to do. So basically in cluster analysis, we have different cases. So we try to identify clusters from these cases. For example, we try to say that this is group 1 and this is group 2. This is group 1 and this is group 2. So this is the purpose for cluster analysis, right? So we have to check what is the uh, purpose of my study, and according to the purpose of my study or research, am I using the correct statistics or not, or whether the assumptions are met or not, whatever statistics I have chosen. Then further coming to how. The how part is simply the steps involved. So the steps are how you are going to uh, go about your analysis, how you are going to run it on SPSS, how you are going to interpret it in terms of output, how you are going to interpret the output and make meaning out of it. So this is the steps involved, is the how you are going to run the analysis and how you are going to interpret. So these four things, what, when, why and how, is very important, a crucial factor when it comes to research. You have to be very clear that all these four questions, you have answer to all these four questions, then only will have the clarity for the research. Okay, moving ahead. So as I told you that we will be going through these topics, so let's start with the basics of SPSS. So the SPSS, the latest version of SPSS is SPSS 26, and it was launched back on 9th April 2019. So let's open SPSS and see what are the different, how it looks like and what are the different things. Okay, let it take the time, and let me, okay, here it is. So this is how IBM new version of IBM, that is IBM 26, looks like. So we have two windows here basically. So one there is, this is video window where we have two tabs. The first tab is data view and the second tab is variable view, and there will be another window which is a output view. So whenever we'll be running any analysis here, so we'll get one more window here which will say that it's an output view. So the output window will consist all the analysis details or results of the all the analysis which we are going to run. So we can see we have different columns and rows here. So it's more or less looks like a Excel sheet. However, so there are some difference. The difference are here each column represents a particular variable. So suppose I have a research where I have 3 to 4 variables. The variables may be name, age, gender, and so on. So we have some chats. Okay. So we have different variables. So each variable is represented in terms of a column. So we may have the first column as name column, the second column or the second variable as age, the third may be gender, the fourth may be income, the fifth may be date of birth, and so on. So each column will represent a particular variable, and then we have rows. These rows are actually different cases or different people. So let's do one thing. Let's start with inserting some data here. So at the very first, what we have to do is we have to go to the variable view and define the variables. So first we have to tell the system, we have to tell the SPSS that what are different variables on which I have collected my data on, or on which I have for my research. So for example, I have different variables. Let's say the first variable of my research is name of a person, and let's say the second variable is age of a person. The third variable, let's say we have a gender of a person, then income of a person, then let's say we have date of birth. Let's write a short form, date of birth. Further, so suppose we are dealing with these 5 variables. So again, if we go to the data view, we can see these 5 variables has appeared in the column section. So each column represents the different variable I am dealing with. Now further, going to the variable view, I have to tell the system that what type of variable is this. So for example, name is a string variable. String variable means that it is written in terms of alphabets, right? So we have different types of variable available here. We have different types of variable available here: numeric, comma, dot, scientific, date, and so on. So however, technically uh, there are only 2 types of variable. The first variable is numeric and the second variable is string. Okay, and the rest, that is comma, dot, scientific notation, date, dollar, custom currency, all these are just variable form or a way of representation. So we'll be coming to each and every one of them in detail. Okay, so let's say string, let's say name. So name is a string variable. That means it consists of alphabets. It consists of alphabets basically. So we have to be aware that on a string variable, basically we can't run any sort of analysis, right? We cannot run any sort of analysis. For running analysis, it has to be a numeric variable. So okay, we selected as a string variable. Then we have something called width. The width represents how many characters your variable is going to take. So suppose if I have assigned a width of 8, that means that my system will accept any person with a name having 8 alphabets on it. Okay, at max 8 alphabets. If it exceeds 8 alphabets, then the system may not take it. Okay, so it says that how many characters the system should store, the variable should store. Further, these are decimals. Decimals are logically the same thing. So generally we don't have decimal points for string variable for alphabets, and we have a decimal point for numeric and so on. So when coming to age, so again age is something which is numeric, which is expressed in number. So the type of the variable for age will be numeric. We select this as numeric and we define the width of the variable. So technically we don't have any person who will be more than who will require more than a 3-digit number for age, right? So maximum it will be 100 or 120. No one will be more than 999. So that's why 3 will be the maximum. Or if in our case the research, if the participants have research participants are of age in 2-digit numbers, so we can select 2-digit numbers. So it's depend upon the sample. And again, we don't have any decimal points for age when we express age, right? So let's go to the data view and see. Let's type some name. So okay, so we see that each row here is representing a particular case. Let's see. Let's say that the different age of person is this much, and the gender is male. Okay, we haven't defined the gender variable. Okay, let's go to the gender variable and see. So gender can be expressed in either male or female. We can write male male or female female, or it can be expressed in terms of 0 and 1, and then we have to tell the system that 0 means male and 1 means female. So there can be two ways. So let's go for the first way, that is let's define it as a string and write it as male 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 and then female. Then coming to income, income variable can be obviously will be expressed in numbers. So let's say it is okay, 1 million. So suppose it's 1 million, so we have decimal places. If we require decimal places, then we have to keep it. If we don't require, we can just remove it by making the decimals as 0. Further, what we can do here is, see, you can see that we may have problem in reading any number which is bigger in terms of income. Okay, any bigger number, and when we don't have comma or separators between them, right? So it may be difficult to read whether it is 1 lakh rupee or whether it is 10 lakh rupee or it is 1 million and so on. So we have some options available here. What we do is nothing but just we select the income type as comma. So as we will be selecting the income type as comma, variable type as comma, so just see what's the change which is going to happen. So we have the separators now. We can see that we have comma as the separators now. Okay, so technically this comma variable type is nothing but numeric type of variable, but there are separators in between. So it is helpful for us to read the numbers better. Further, we have dot. If we change the variable type as dot, then what will happen is, see, the separators has changed from comma to dot. Okay, so again we have date of birth. So again, date of birth is expressed in day, right? Year, day, year, and month. So we select it as a date variable, and we have different ways in which we can write month, day, and year. So as per your convenience, you may select the different types. So let's say we take it as the first one, that is DDMMMYYY. So it will be so we can see we can insert it in this way. Okay, 25th December 1992. So again, if we don't want to, if this is not convenient for us, then we may also change the format in which the date of birth appears. So we can again go to the variable view we can go to date and we can select the desired format. So again, see, it has changed. So likewise, the variable views, in variable view we have to define the different variables. We have to tell the system what it stands for and what type of variable it is. We have further two or more things like dollars. If we have to uh, if dollar is a currency basically used in US and some other dollars we have in different countries. So a dollar, whenever we have to input a variable like income in terms of dollar, suppose let's change the income variable in terms of dollar. So what will happen? So whatever income we had, it will be changing to dollars. So that's a lot of income, I guess. Again, what we can do, so in India we don't have income in dollars, right? So what about our currency? So we can insert our currency also. So for that we should have to go for custom currency, and in custom currency if we select the income variable type as custom currency, then we see we have this CCA, CCB, CCC, CCB. So these CCA, CCB is nothing but custom currency A, custom currency B, custom currency C, custom currency D and E. So what we have to do is we have to go to the edit section first and then go to the options, edit options, and once we are there in options, what we can do, we can go to currency, we can suppose we can write INR. So this will be Indian National Rupee. Or if we want to use the sign for rupee sign, Indian rupee sign in terms of uh, in respect where we want to use INR. Okay, so what we can do, we can just go to Google. We can just Indian rupee, rupee symbol. We can find it and then we can select the symbol, copy it from Google and go to a system, and in place of INR we can select the uh, Indian symbol, Indian rupee symbol. So we can see that a box appears here. So a box appears here. So this box basically is nothing but the Indian rupee sign. Okay, since SPSS system doesn't recognize this character, so that's why it is represented it as a box. However, if we copy this variable, if we are going to copy this variable, just a second. Okay, so we change the income variable as custom currency. So now see what's the difference. So we can see we have a box sign here, right? So if we are going to copy this variable, this in any text on notepad, then what will happen? The rupee sign is going to appear. So technically it's there, but since the system doesn't, SPSS doesn't support the character, so it's showing as a box. Further, we can go to um, there is one more variable type, that is restricted variable type. This restricted numeric variable. So this is a very easy concept again. So suppose let's work with age. So if I change the variable type for age to restricted numeric integer with 0, so let's see what's going to happen. So we see that there are zeros added. So let's see what is the width. The width of the age is 3. Okay, let's make it 4. So the width of the age variable is 4. That means 4 character can be accommodated, right? So since we have 2-digit number with us, so there will be 2 preceding zeros. Okay, so depending upon the width, there will be preceding zeros. So it's mentioning that it's a way of representation, and for if it is easier for us to read. then it is helpful. Otherwise, we can select it as numeric also. Variable type as numeric also. Okay. Then coming further to labels, values, and missing values, etc. So coming to label. So suppose this DOB. Okay. So what DOB stands for? It may be that we may forget. So we can write it in the label section. Date of birth. Again, if we have a variable with a very long names, for example, let's consider we have a variable like happiness, happiness of youth. Okay, then we see that in the data view, it's taking a lot of space, and so what we can do, we can just change the name and we can change it to HY and we can write it in the label happiness of youth. Okay, so we see that we have a variable HY, and if we bring a cursor on it, we check the label that HY stands for happiness of youth. So the label, this label column, we can label a particular variable in different ways. It can be either used for to understand that suppose we have a question or an item named Q1. Suppose if we want to remember that to which question, to which dimension this belongs to which dimension, or what the question 1 is measuring, or technically what is question 1. So we can either write the whole question in label, or we can write what the question 1 is trying to measure. Okay, so this is all about label. And then we have values. Okay, so let me go to the chat thing. Okay, so I think we are clear till label, and now we will be proceeding with values. So in most of the cases we use Likert scale, right? Likert scale or some other type of scale. For example, let's say we have gender. Okay, so we change the gender to numeric, and we in terms of we represent the gender. So further continuing with uh, different variables. So let's do one thing. Let's change the gender, express the gender in terms of 0 and 1. I think, yeah, we have this data file. Okay, let's express the gender as 0 and 1. Okay, so right, and so here if we mean that 0 means suppose 0 means female and 1 means male, then in that case we have to tell the system that what I mean by 0 and what I mean by 1. Okay, if I am representing uh, any type of thing like we have in Likert scale like strongly agree, so we have to tell the system what we code it as 5 4 3 2 1, right? So we have to tell the system what I mean by 5, what I mean by 4, what I have to mean by 3, and so on. Similarly, we can code gender as 0 and 1, and we can tell the system that what is 0 and what is 1. So here we can see that Anshu and Arushi is 0, so 0 is female and 1 is male. Okay, so I have to tell the system that 0 means here. So we just add the value 0 and we add the label female to it. Then again 1 means male. Okay. So now the system understands, okay, that what is the meaning of 0 and what is the meaning of 1. So if we go to how can we know about it? If we go to analyze, we go to frequencies, descriptive statistics frequency, and we just select the gender thing in the variable, and we don't select any other options, and we just click OK. So it will count how many gender we have. So we can see that for female we have 2 people, and as a male we have 1 people in our data set. So technically this tells us that the system is now understanding that what I mean by 0 and what I mean by 1. Moving further, so we have uh, value. So now I hope you understand what value means. So suppose if there is, let's take example of a Likert scale. So happiness, happiness of youth. So if I say that happiness 5 equals to, likewise we can add 3 for neutral, 2 for disagree, and 1 for strongly disagree. So likewise we can make the system understand what we mean by 4 3 2 1 or 0 1 or whatever things we have taken into account. Further, we have things like columns, missing, alignment, and then measure. Okay, so let's understand column first, then I will be taking you to the missing thing. uh, See here, the column and alignment, these two things are nothing but a decorative aspect of SPSS. When I mean decorative aspect, that means that it is nothing to do with the statistics, rather it is just how our data is going to look. For example, let's go to the data view and see that what is the width of the column. Okay, name. What is the width of the column with variable name? So we can see this, the width is this much. So if we increase the width like this, if we increase the width, let's see in the variable view, the value here has changed. The value of column has changed. Now if we are going to decrease, again the value will change in the variable view. If we again go to the variable view, we can see that the value has changed. So basically it is more of a decorative aspect for different variables. It has nothing to do with the analysis. Again, the second decorative aspect is alignment. So alignment is, I think we have used in most of the softwares like MS Word, then Office softwares obviously. Then left alignment, we have left alignment, right alignment, and the center alignment here. So how I want my data to be aligned. So suppose I want my name data to be aligned in the center way. So it will be aligned like this. If we can change the alignment to right alignment or left alignment, so on. So let's try to change the alignment, right alignment. So see, the alignment has changed. So it's just a decorative aspect of SPSS. Now, again, one of the important aspect is measure. So as we know, we have different measures available. Or levels of a scale available. In SPSS, we have three basically, that is nominal, ordinal, and scale. So basically, in SPSS, what happens is interval and ratio scale has been clubbed together. Interval and ratio scale of measurement has been clubbed together to form a single uh, measure, that is scale. Now I will be briefly covering what is meant by nominal, ordinal, and interval and ratio scale. So technically we have 4 scale. Okay, since this is an important part on the basis of measurement of different variable, we decide what type of analysis we have to go through. So there are 2 types of variables. Technically, variables can be categorized as 2 types. So it can be categorical, it can be continuous. Okay, so in categorical, we have again 2 types of variable, that is nominal, and then we have ordinal. Okay, Then we have in continuous variable, we have two things, that is your interval and ratio. So I'll be briefly covering this. However, if you want to go it in details, you will just receive a mail after the webinar. The mail will consist of some of the reference material to read, and you will find the details of the about the levels of measurement there. Okay, so when we say nominal variable, we mean like something which has to do with on grouping, something which has to do with grouping. So for example, male, female, and others. So this has gender. On the basis of gender, we can classify people on male, female, or other, right? Like systematically we can uh, classify people as in different classes, class 1, class 2, class 3, or like this. So whenever we talk about nominal variable, we are talking about groups. Basically we are talking about groups which are formed on a particular basis, groups which are formed on a particular basis, on the basis of gender, on the basis of other things, or all the people with name starting from A, all the people having the name starting from B. So if we form the groups like this alphabetically, then it will be considered as a nominal variable. So technically nominal variable is a categorical variable. Then we have ordinal variable. Whenever we say ordinal variable is has to do with something with rank. So what we do, if something we rank different cases as first, second, third, fourth, fifth, right? So if we rank different cases, then that type of variable is known as ordinal variable. Suppose in our classes, when we used to study in a university or class school, so school colleges, so technically we had someone who used to stood first, and then there was a person who used to be second, third, fourth, fifth, and so on. So technically these are different ranks. Okay, these are different ranks. So technically what variables on the if we categorize them on the basis of their ranks, then we say that the level of measurement has been ordinal. So for example, if we have different people of different height, if we categorize them on the basis of their height from tallest to shortest or shortest to tallest, then it represents a rank variable. Then again, continuous variable may be two, interval and ratio. So for continuous variable, we have what we have is uh, for example, most of the social skills like which we have for like measuring personality, we have different types of dimensions, we have different types of skills, and most of the social variables are interval in nature, right? So for example, whatever we when we use Likert scale, whenever we use Likert scale, that is a 5-point scale, technically it represents a interval level of measurement. It is a interval level of measurement. So we have something called strongly disagree, we have something called disagree, we have neutral, or we have agree and strongly agree. So we can see that each of the measure is situated equally distant from each other. So we consider that whatever the distance is in between strongly disagree and disagree, it is same for disagree and neutral. Okay, so there is a continuity in the fact. So that's why we say that it belongs to the interval scale. Further, what can be done? The next is ratio scale. The ratio scale is more like whenever we measure something which has to do with physical quantities, like most of the biological aspects, like glucose level, contamination level, etc. So all these things are interval scale. Okay, technically what is the sorry, all these things are ratio scale. So technically what is the difference between interval and ratio scale is that for interval scale we do not have the absolute zero, but for ratio scale we have absolute zero. For example, so for interval scale we have absolute zero. For example, we can say that the glucose level in a person's blood may be 0. Obviously, if it is 0, the person has died, but it may be 0. Okay, the contamination of a particular of a particular object with virus or bacteria is 0. Then in that case, we can say that the bacteria count is 0 or the virus count is 0 on a particular object. So things which can, where 0 can be there, where 0 can exist, is technically belongs to ratio scale. However, variables where 0 can't exist, like no one can have a 0 IQ, no one can has a 0 personality dimension. So technically these factors represent a interval scale. So however, when it comes to SPSS, SPSS has clubbed together interval and ratio scale, and on the basis of different levels of measurement, we decide what type of analysis we are going to run. Okay, so for nominal or ordinal, we go for non-parametric statistics, and for continuous scales like interval and ratio, technically we go for parametric statistics. Okay, so one more thing is left, that is missing. Okay, to make you understand what is meant by missing, let me go through the actual data. Let me open one actual data for you, research data, and then I can make you understand what missing means. Okay, then so we can let's see how we can import our data. So we go to file, we go to open. So when we go to open, we have many options available. If we click data, and then we have different files like .sav. So all these .sav files are basically files related to SPSS. So SPSS also supports other files like .sys, portable, Excel, CSV, text, SAS, starter database. So all these are basically serve different purposes. Let's talk about this in brief, and then I will let you know about the missing value. Okay, so the spaces for spaces statistics, we have extensions like .sav, .zasav. For SYS is the older version. The older version of SPSS used the extension SYS. By older version, I means more than old, like before 1990s. And then we have something called portable. So the portable version is like if you are using a older version of SPSS like SPSS 14, 15, something like this, and you have switched to 26 and you have a file in 14 or 15, it may not open here. So we have to convert it into a portable form, and then we can open it in the newer spaces. So again, we have something called Excel. So this Excel is one of the most commonly used data file to used for importing data. So what we can do, most of us use Google Form or other type of forms to collect data, and then we copy it in Excel, and from Excel we can directly copy and paste, or we can open the Excel file in SPSS. Again, we have CSV, and we have text, SAS, and strata. So basically this SAS and strata file, SAS, strata, and DBase. So all these are different types of analytical softwares, data analytical softwares, and they have their respective extensions which can be opened in SPSS. Okay, and then we have Lotus and Silk. All these are different types of forms. Like we have Google Forms. So all these are Lotus and Silk are different types of forms. So now let's open data for you. So okay. So technically we have this data set where we have ID, we have date of birth, we have different rank, gender, whether a person is an athlete or not, height of a person, weight of a person. So technically we see we have almost all type of variables here. Okay. So now I was telling you about what is meant by missing value. Okay. So suppose what is missing value? See, here we can see that it may be cases where people have not filled up the value for themselves, right? There can be a cases where we don't have a but value for a particular variable for a particular case. So these are basically missing values. Okay, so these are basically missing values. However, uh, when we are coming to this variable, however when we are coming to variable view, when we talk about these things, so what we can do actually here, the system assumes that there are no missing values. Okay, and then we have something called discrete missing value and range plus or optional discrete value. Okay, so what these different things means. So technically, with the help of this dialog box, with the help of this function, we can tell the system whether whether we want to take different uh, values for us or not. Suppose if we don't want to include a particular value in our analysis. For example, if I don't want to include, let's say for height, all the people who are taller than 60 centimeter, if I don't want to use it in my analysis, all the people who are taller than 60 inch, not centimeter, 60 inch, then what we can do, we can just go to the variable view, we can click on range, and we can say that apart from all the people who are above 60 to 80, which will be the maximum thing, should not be taken in the data. So by assigning this, I have told the system that I don't want any data between 60 to 80 to be included in my analysis. Now let's see if I go here and just I run uh, frequency. We check the okay. So see, it says that we have only 33 valid cases and the rest 402 cases are missing. So technically we have 402 cases which lies between 60 and 80. I think we have taken a huge range. What we can do is we can reduce the range here. Okay. Let's make it 70. And now run the same thing. Analyze descriptive frequencies. Okay. So now see, we have now 285 valid cases and 150 of them are missing. 150 of them are missing. That means 150 of the people lie between the range, heights lie between the range 70 inches to 80 inches. So this is the way in which we can select and we can tell the system what range of values we don't want to include in our analysis. Further, we can make it as a discrete value. A discrete value means if I don't want any person having suppose we can say having a height of 65 centimeter to be included in my analysis, it will just remove the people who have the height exactly 65 centimeter. Okay, so if we can remove the cases by assigning a particular value to 65, we can also say that I don't also want any person with having the height of 69 inches, and then again we can say that we don't want any person who has a height of 80 inch. Okay, so this is what we do with missing values. Okay, now we have to make sure that here in the variable view, when we have to deal with the missing value, this missing value means what we want to exclude from our analysis, right? What we want to exclude from our analysis. However, there is one option. If we suppose don't know these different missing values, right? We have different missing values. So we have a missing value for case number 9. Suppose if I don't want there to be a missing value, and if I want that this should be filled, okay, this should be filled. So we have different ways to fill the missing value. We can go to transform, we can go to replace missing value. So here in replace missing value, we can tell
सेटिंग हो जाती है, सॉरी की जरूरत नहीं है, किसी चीज की जरूरत नहीं है.
we can tell that how I want to replace my missing value. It can be done in multiple ways, like series mean, mean by endpoints, median, and linear interpolation and linear trends. So there are different ways in which this can be done. Okay, so let's go and replace the missing value for height. So we see that we have a new variable for height where we have no missing values. So what we did, we changed the missing value with the series mean. So I think we are clear with these topics, like what is meant by data view, what is meant by variable view, what is the output window, how we can name the variable, what is meant by the characteristics of variable, that is type and etc. And how to open a file. I will be showing you how to save a file, and then we will be coming to transform. In transform, we have dealt with how we can replace a missing value, right? How we can replace a missing value. So see there. Okay, now coming to how we can save a particular file. So it's a very easy thing. We go to file and we go to save option, and we can just save the file. It will come, you can give the file name, you can select where you want to save the file. Just like any other software, you can choose the location and choose the format in which you want to save the file, choose the extension, and then you have to click save. So it's a very simple process, nothing complicated. Now coming to other things like transform. Okay, coming to things like transform. What is meant by transform? So uh, we have something called transform, which from transform we can do multiple things like compute variable, decode into same variable, decode into different variable. So what are the different aspects, what are the different options we have here? So let's say, like uh, like we can see that for gender we have 0. By 0, suppose I mean female, and by 1 we mean male. For 0 we mean female, and for 1 we mean male. So suppose if it is hard for me to understand and I wanted to change it to M and F, right? Male and female, M and F. So what we can do, we can go to transform, decode, we can recode the variable. Okay, if you want to just change the thing, we can just recode the variable. So there are two options: recode into same variable, recode into different variable. Now what is the difference is, when we choose recode into same variable, there will be the whole gender, that 0 will become female, and there will be no new variable form, there will be no new columns which will appear, and this column will change itself, right? This column will change itself. And if we select the other thing, that is recode into different variable, in that case a new variable will appear, like gender 1, and where we have a 0 in terms of this, in this column there will be a female written there. Okay, so when we use into a different variable, that means a new column is going to appear. When we recode into the same variable, that means the column is going to change, the value in the column itself is going to change. So let's go and let's try it once. So we go to transform, we go to recode into same variable, and we tell the system that for old value 0 I mean male. Okay, So it's, I think it's not a string variable, that's why. We just tell the system that just whatever we have as zeros, just change it to male, and whatever we have is as one, just change it to female. We click OK, and now we say that we have M and F. Okay, so what we actually, why it has not taken the full male and female, because the width was defined as 1, so that's why it only took one character, that is M and F. So all the 0 has changed to male and all the 1 has changed to female. Okay, so if you would have selected recode into different variable, what would have happened, that new variable would have appeared here, which would have a recorded value, right? So coming to the next thing, that is your compute. So now I think we are done with recording variable and replacing missing value. So you can also study, you can also go through the notes regarding replacing missing values and recoding in the reference material which I will be providing to you. Okay, so in the mail you will be having each and everything after the webinar provided to you. So then coming to compute, what the compute function stands for. So technically, many a times we have many subscales in a system, right? So compute, or if we want to just add 2 or 3 variables, or if we want to multiply 2 or 3 variables, right? Okay, then how it can be done is, so target variable is the new variable which will be appearing. So suppose if I want to compute, okay, suppose what I want to do is I want to add height and weight. I want to add height and weight. Okay, so we have 2 variables. The first variable is height, again the second variable is weight. So if I want to add, so we can write sum of height and weight, HW, and we can write here, so it's just like a calculator, more or less, height plus weight. So if I click OK, we will see that a new column is going to appear, which is just going to sum the height and weight of a individual cases. Further, we can use, so when we are going to use transform is, suppose we have a scale, we are using a scale where we have different questions. For question 1 to 5, all the question 1 to 5 belongs to a same, we can say same dimension. So in that case, a dimension score is necessary for us to be computed, right? So we have different questions. For example, question 1, question 2, question 3, question 4, question 5. So these 5 questions, all these 5 questions respond technically measures the same dimension, D1. So suppose I want to add all the scores which I have obtained on each of these questions. So we can use this compute function, compute variable function available in SPSS. Further, if you want to use any complex formula like height square divided by weight and so on, anything like this, okay, like if you want to go and calculate the BMI, okay, so any formula if you want to insert, we can just insert it with the help of these numbers and these symbols which we have. So here we have plus, minus, multiply, divide, this is power and so on. So all the details regarding each of these different symbols has been provided in the reference material too. So I am just rushing a bit because we have limited time and we have a lot to go through. So that's why I'm rushing a bit actually. So here is compute, record, replace, and the missing value. So coming to descriptive statistics. So technically we have different three types of statistics: descriptive, inferential, and predictive statistics. So the descriptive statistics tells us more about the sample, more about the sample characteristics, its mean, median, mode, its measure, its variability like SD, its variance, and so on. How a sample is actually. So uh, it can be found out in descriptive statistics. So what are the different things which we can find in descriptive statistics are? So let's go to the thing like analyze. We go to the system, we go to analyze. We have something called descriptive statistics here. Under descriptive statistics we have different options like frequency, descriptives, explore, and then we have cross tabs, we have ratio, then we have pp and qq plots. So let's go to the first thing, that is frequency. So suppose I want to know that suppose I want to know that how many male and how many female has participated in my research, right? How many female and how many male has participated in my research. So what I'm going to do is just I select the variable gender in the variable section and click in the frequency table and just click OK. So we are not going to do anything else. So we see here a table appears in the output window which says that we have 222 females, we have 204 males in our as a sample in our research, and we have 9 people basically. Okay, so I think we have set a missing thing. Okay, so 100% of the data is valid. Okay, so we have 222 people as female and 204 people as male, and for 9 people we don't know whether they are male or female. Okay, so we don't have the data for 9 people. So what we can do, we can, when we go to analyze, we go to descriptive statistics, it tells us more about the sample characteristics. For example, how many male and female are there, what is the age of the population or sample which we have, what is the mean age of the sample which we have, we may calculate what is the mean height of the sample which we have. So again we can run one more analysis like what is the mean height or weight of the person for the sample which we have. Okay, so what we can do, we can run different type of analysis. We can run the mean, median, mode, all the measure of central tendency. Then we can calculate the quartile, we can calculate the skewness and kurtosis. Similarly, we can check the measures of dispersion, right? Maximum, minimum, and then we can check the range, variance, standard error. So we can select all these things. We can also have a charts if we want, diagrams if we want, and so on. So let's click, let's see what we get. So here's a table which we get, which says that out of 376 cases, valid cases which we have for weight, the mean was found out to be 181. Mean 181. This mean represents the average, right? The average weight of person. The median was found to be 172. The mode was found to be 151. Again, we have the different measures of variation, dispersion, like standard deviation, variance, and so on. Then we have something called skewness and kurtosis, which has been calculated here. So basically, skewness and kurtosis, it has to do with normal probability curve, NPC, as we can see here. What skewness and kurtosis mean? So see, we have different types of normal probability curve. So we have a positively skewed curve on the right side, we have a negatively skewed curve on the left side, and then we have a normal curve in the middle, right? Then similarly we have um, okay, so we can see the different types of distribution we have. So we have leptokurtic, we have normal, and we have platykurtic. So the normal distribution is also known as mesokurtic in nature, right? So in the analysis we have seen that so in our output we have seen that we have a skewness value more than 1, we have a skewness value more than 1, and we have a kurtosis value more than 1, right? So the idea behind this is like the reference we have which we have to check the kurtosis and skewness is, say we have mentioned it here. So if the value for skewness, if the value is for skewness is greater than +1, then we consider that the distribution is right skewed, okay? Or if it is less than -1, then we consider it is left skewed, okay? So once we have positively skewed and negatively skewed, right? So here right skewed is positively skewed and -1 is negatively skewed. Similarly, for kurtosis, if the value is greater than +1, we say that the distribution is leptokurtic, or most of the cases are grouped around the mean, clubbed around the mean. And if it is -1, that means the distribution greater, we have a greater range, we have a greater range, we have a greater variation in the data. Okay, so it may range from +1 to minus. If it is less than -1, then it is platykurtic. If it is more than +1, then it is leptokurtic. So we can go through this. Let's check what it comes for us. So here we can see that we have a skewness around just slightly more than 1. Okay, just slightly more than 1, and then we have kurtosis again more than 1. So technically we can say definitely this is not a normal curve. Definitely this is not a normal curve, and it is both it has both skewness or skewed. It is both skewed and it is basically leptokurtic in nature. Okay, so we have to refer the reference whenever we have to see whether the curve is skewed or not, whether it is leptokurtic or whether it is platykurtic. We have to check the kurtosis or skewness. Okay, then coming to since these are the basic things, mean, median, mode, we can check it in the table itself. Further, coming to how we are going to analyze, this is the quartile. See, percentiles are nothing but the quartiles. So this is P25 is the lower quartile, P50 is the median again, and P75 is the upper quartile. So what we have to do is how we are going to check whether a distribution is following the normal probability curve or not, whether the distribution is following the normal probability curve or not, whether it is normally distributed or not. So the idea behind is that we have to check it with the help of a test, that is which we will be finding in explore. So we go to analyze, we go to descriptive statistics, and we go to explore, right? So we have a test named KS test. How we can check the normality of the data? How can we can check the normality of the data? Suppose I want to check the normality of both height and weight. Okay, we have to check the normality of both height and weight. So what we do, we go to explore. We just select height and weight as a dependent list, and when we go to plots, and here we can see we tick normality plot with test. So basically if we check the box here, normality plot with test, it is going to check the normality for us, whether our data is normally distributed or not. Okay, So let's click OK here. Let's see what we did. Okay, so it says we have some missing values. Let me check. Okay, here we have. It was taking time actually. It was there already. Okay, so height and weight. For height and weight, we can see we have 81% of the valid cases. 81% of the valid cases, that is n equals to 435. And we have different descriptors for height and weight, which we have already gone through. Now coming to the test of normality, which we have to check. So here, what is important is we have to check the KS test. The KS test. So both KS test and Shapiro-Wilk test is the same test, and it is utilized to check the normality of the data. And basically, the more used one is KS test. So what is the idea behind this? Is that if the KS test is significant, that means if we find the any value here that is less than 0.05, that means KS test is significant. If we obtain the value of KS test as significant, that means my data is not normal. And if I have a value greater than, that is KS test is not significant. If I have a value greater than 0.05, so if you have any value greater than 0.05, we say that my data is normal. Okay, so technically the null hypothesis for KS test is that the data is not following the normal probability curve, and the alternate hypothesis is that it is not following the normal probability curve. So it is better that we don't reject the null hypothesis. Okay, so the more parametric assumptions are met, the more the normal the data we obtain, it's better for our analysis, as parametric test is more powerful as compared to non-parametric test. Now further moving ahead, so we can see we have a histogram here, and it somehow is looking like a NPC, and then we have something called QQ plot. Now this KS test is technically test for normality, is technically seen along with the QQ plot. Okay, so here the KS test suggests that both height and weight is not normally distributed. That means a sample is not following normal probability curve. Okay, which could be also seen it was skewed, and it was it was leptokurtic in nature. So it can be the same thing can be cross verified from many places. So we can see the QQ plot here. The QQ plot, in QQ plot we have expected normal in the y-axis and observed value in the x-axis. Okay, observed value of height, observed value of weight. So suppose this is for height, so these are the observed value of height, and these are the expected value of height. Okay, so then we have a line, the straight line. This straight line represents the normal probability curve. This straight line represents the normal probability curve, and then we have these small data points here. These points represents the data, each cases. These points represents each cases. Now the more the cases are overlapping the line, like here, the more the cases are overlapping the line, that means our data is following normal probability curve. But we can see that we have some cases which are not overlapping on the normal probability curve line, NPC line, right? which are not overlapping on the NPC line. So basically these are the outliers or extreme values we can say. So basically if we identify these outliers and remove it, if it is possible for us to remove, and we remove it from a data, then what we can achieve is normal probability curve. So one of the way is to check the data for its normality. If it's normal, then it's okay. If it's not, identify the outliers. On identification of outliers, you have to just omit the outlier, delete the cases. Okay, and if it is not possible for you to omit the cases, for example, if your data size is very less, if your sample size is very less, and you cannot afford to delete the cases, then in that case you have to go for the non-parametric statistics. Okay, so now coming to how to identify outliers and what are the other assumptions. So see, we have different ways to identify outliers. One of the way is with the help of a box plot, and the other way is with the help of extreme values. So what we can do is, let's go to the height thing and let's identify the cases where the heights are not matching the outliers for height or extreme values for height. We to go to descriptive, go to descriptive statistics. So we can click to outliers, right? We can just click outliers here and then we click OK. So we go to descriptives, analyze descriptive statistics, then we go to explore, and in explore we just select dependent. In dependent case we select height, we go to statistics, we select outlier and we click continue, and then we click OK. So let's see what we have. So see, this is something which is known as a box plot. This was made earlier, and this is your extreme values or the outliers. So for height, we can identify that case number 326, case number 397, case number 407, case number 98, and these cases are the extreme values. So if we delete these cases, then we are going to achieve normal probability curve probably. Okay, so if at the expense of 4 to 5 cases, if we can achieve the normal probability curve, it is very much recommended, since parametric statistics is very powerful as compared to the non-parametric one. Okay, similarly we can identify the extreme values from the box plot. This is something known as a box plot. Let's try to understand what this plot represents. So this, on y-axis we have height, and on x-axis we have height, and on y-axis we have different values for height. Okay, and then this is a block. Here the central line, the bold line, represents the median. This represents the upper quartile, and this represents the lower quartile. Technically this is Q3, this is Q2, sorry, Q1, Q2 is median itself, and then we have this as a range. This is basically the range. So with the help of a box plot, basically we can see what is the quartile, what is the value for upper quartile, lower quartile, median, and then these are the outliers. So technically what we can see the name cases here. So just let's remember one or two cases, like 397, 98. Okay, 397, 98. Now if we refer to the table, where we have extreme values, we can find these correctly, these two cases here, 397, 98, right? So outliers can be identified both with the help of extreme value table or with the help of a box plot. Okay. However, the box plot gives you some more idea. The idea is we can see how uh, what is the basically the deviation of the data. If the size of this box, if the size of this box is small, that means my variance is less. If the size of the box is more, then the variance is more. If the suppose this size is more, suppose like this, then technically what is happening, Q3 and Q2, Q1 is more apart, and that means the range or the deviation is more. Okay. Based on, so we have some questions. Let's go to the questions first, and let's uh, okay. Based on the values, can we identify positive or negative kurtosis? Yes, based on the values of kurtosis, we can identify positive or negative kurtosis, right? We can do it. So basically, the value is in positive. Just in the slide, we can see this, the answer to this question. So if the value is greater than 1, this is a positive kurtosis, and if it is less than 1, then there is a negative kurtosis, which is also known as leptokurtic and platykurtic. Um, okay, okay, nothing else. Okay, so going further, if our assumptions are met, if our assumptions of homogeneity is met, then obviously we are going for parametric statistics, and if your assumptions are not met, we are going for non-parametric statistics. Let's check what are the different assumptions which we have for using parametric and non-parametric statistics. So technically, inferential statistics are of two types, that is parametric and non-parametric. For using parametric statistics, that is t-test, ANOVA, all these are parametric statistics. So for using parametric statistics, what is we have to assume that the distribution is normal. We have to check it with the help of a KS test. We have to see that that the data is homogeneous, that the sample is homogeneous, the variance is homogeneous. So this is the assumption, homogeneity of mean. So this can be tested by a Levine test. So I'll be running a Levine test in front of you to give you an idea of it. Then technically for parametric statistics, the thing should be in a ratio or interval scale. The data should be in ratio or interval scale. And likewise for non-parametric, it should be in ordinal and nominal scale. Like for chi-square, we use ordinal and nominal data, right? We use chi-square to make meaning of nominal and ordinal data. Similarly, for we have other non-parametric statistics like Spearman correlation. Then we have Mann-Whitney U test, Friedman, ANOVA. Then we have many other alternatives. So parametric and non-parametric statistical methods are like parallel world. Okay, they are like parallel world more or less. So technically, for each parametric test, there is an equivalent non-parametric test. However, parametric test is more powerful as compared to the non-parametric equivalent. Then the data should be independent of each other. That is the cases, that the value of the cases should be independent. The response should be independent of each other for different people participating in the research, right? Their response should not be dependent on each other. Then the use of central measure in the parametric statistics is mean, whereas in non-parametric it's median. And benefits is that conclusions can be drawn and more easily generalized. However, for non-parametric statistics, since we have outliers and since we have letter generalizability for the results which is obtained from non-parametric statistics, so it's always better to go for a parametric one. And So the idea is to identify the outlier, and on identifying the outlier, you can just remove the outlier at the expense of 4 to 5 cases. And if it is not possible, then obviously you have to go for the uh, non-parametric equivalent test. Okay, so let me run one more analysis for you. That is your Levin test. Levin test is a test for homogeneity of variance. So how to do it? Just go to analysis. So t-test assumes homogeneity of variance basically. So let's go to analyze, descriptive statistics, and we go to explore. Okay, so suppose I want to check in terms of uh, there. Suppose I create two groups, male and female, and I want to check that whether there is homogeneity of mean within the height of female sample and male sample, right? So we have to select uh, in a factor list gender. What I'm trying to do is here I'm trying to make two groups, that is a group for female, a group for male, and then I'm trying to check the height here and here. I'm trying to check that whether the sample, the variance, the sample, the female sample, the variance here and the variance in the male sample, whether they are equal or not, whether V1 is equal to V2 or not, whether variance of female sample is equal to variance of male sample or not. So suppose if we compute mean height for female and mean height for male, so it can, and then we run t-test in order to check whether male or female, whether gender, is there any role of gender in terms of determining the height, or are males more taller than as compared to females. If we have to check any hypothesis like this, like if males are taller than females or not, or if females are taller than males or not. So what we'll be doing, we'll be doing comparison of mean and probably a t-test. A t-test being a parametric statistics, it will be assuming that there will be homogeneity of mean. So we have to check whether there is a homogeneity of mean or not. Okay, so we go to explore. We just select height as a dependent list, and as a factor list we select gender, and then we go to, so we don't need all these now, we just go to plots and we check normality obviously, and with normality, see there is spread versus level with Levin test. So we go to untransformed, we click on untransformed and we click continue, and then we go to OK. So let's see what we get. So that's, see, this is a table which I am talking about basically, that is homogeneity of variance. So in the first table we can see that since, just a second, so we have two tables. Okay, in the first table we can see that both the value for KS test for male and female is more than 0. For males it's more than 0.05, 0.05, and for females is less than 0.05. That means for female it is not normal, for males it is, the distribution is normal. Further we can see the homogeneity of variance, test for homogeneity of variance, that is known as Levin statistics or Levin test. So here what we have to check, again we have to check the significance value based on mean, significance value based on mean. So if this value can be greater than 0.05 or it can be less than 0.05, there can be two things which can be happening. So if it is greater than 0.05 or level of significance which we take, then we say that obviously Levin test, we said that there is homogeneity of mean, or homogeneity of variance, and if it is less than 0.05, it is homogeneity of variance is not the assumption of homogeneity of variance is not retained. Technically, it's heterogeneous. The variance is heterogeneous. All the variances for different groups, that is variance for female and variance for male, is different when we say heterogeneous, and for homogeneous it's same. So take here, on the basis of value, we see that it is greater than, it is going for the first case, that is homogeneity of the variance is maintained. So technically it's fit for analysis t-test, it's fit for t-test, provided it follows a test for normality, provided if we delete some of the cases by identifying the outliers and the female section can be made normal. Okay, so if the female distribution can be made normal, then we can obviously go for a t-test, parametric test. So this is all about test of normality and test of homogeneity of variance. Coming back to the PPT, we see it here. So I think this, all the points have been made clear in this slide. So further in inferential statistics, let's go through them briefly and let's try to understand what are the different statistics and what they are for. In page 32 of the reference material which I will be providing, there will be some guidelines where you will be informed that how you can choose between parametric and non-parametric tests. So, and even can we apply different parametric tests even if the assumptions are not met. Okay, or what is the minimum sample size which we should take for a parametric or non-parametric test. It's better to go for any research with a greater amount of sample size, as we assume the greater the sample size, automatically the variable, the distribution of variable assumes a normal probability curve. Okay, now coming to t-test. So these t-test is nothing but is a part of parametric inferential statistics, and with the help of t-test we do comparison of mean. So we have three types of t-test in a system. If we go to the system, we can see, we go to analyze, we go to compare mean to run t-test, and then we have three types: one sample t-test, then we have independent sample, then we have paired sample t-test. So we have three types of t-test. What are the different purpose of these t-test are? So for example, for one sample t-test, if we have a sample with us, and if we know the population mean, so, and if we know the sample mean of sample and mean of population, right? Mean of population, if which is represented by mu actually. Okay, if we represent, so we can compare whether the sample belongs to the population or not, whether the sample is representing the population or not. So it is a test of basically checking whether the sample is accurately representing the population or not, whatever population I am taking or defining into the research. So it basically compares the mean of sample with the population. Similarly, for independent sample, suppose we have two samples with us, two groups with us, it compares the mean of sample 1 or group 1 with group 2, correct? It compares the mean of group 1 with group 2. Okay, so it may say that the mean varies or not. If the mean is varying, then the difference in mean is due to the probability factor, chance error, or whether there is a significant difference. Paired sample t-test is used whenever we are using repeated measure design. So in repeated measure design, what happens? A single person, suppose a person x1. So a particular observation is taken from x1, and again independent variable is introduced, and again our observation is made on x2. So we can say on x1. So we can see that a single person is going through the observation 2 times. Okay, one is before the intervention and the second is after the intervention. Suppose the question may be whether this webinar for statistics has made a significant change in your knowledge or not. So it will be you x1, and before the webinar your knowledge about statistics will be this much, and after the webinar the knowledge about statistics is this much. And then I will going to run the analysis, that is your paired sample t-test, to compare between the two and check whether the webinar was efficient or not. Okay, so something a hypothesis like this will be using paired sample t-test. Again, coming to one way ANOVA. So if we have to, t-test is fine when we have two groups, when we have to compare two groups. But if we have more than two groups for a particular IV, if we have more than two groups for a particular IV, then one way ANOVA is required. More than two groups, right? So ANOVA stands for analysis of variance. One way ANOVA. So technically, one way ANOVA means one IV, one independent variable, right? So suppose the independent variable, suppose I want to see the effect of light on learning, So here, lighting condition is an independent variable. We may have 3 levels of it. So the 3 level will be very bright light, normal light, and dim light. So we have 3 levels. And suppose we have 20 people here, we have 20 people studying here, and we have 20 people studying here. And we want to check the learning pattern, learning outcome. So technically we have more than 2 groups, right? We have 3 groups here. Or more than, we have only one IV, but we have more than 2 groups to compare. So this is a case of one-way ANOVA. Similarly, there may be a two-way ANOVA, which may be, there may be 2 IV, 2 independent variable, and multiple groups. The example may be light and sound. So for light, we may have 3 conditions, L1, L2, L3. And similarly for sound, we may have 2 conditions, S1, S2. Okay, so we can see now we have 6 groups to compare in different combinations. 6 groups to compare in different combinations. So one way, two way, and factorial ANOVA, all these actually tell us about the number of IV we have used. Okay, and there can be multiple groups. Okay, let's delete this. So technically, whenever we run ANOVA, what we get is a F-test. ANOVA is also known as F-test. What we get, the answer is, it says about it, we have to interpret it as at least one group is different from other. At least one group is different from other. So if the value for F-test is significant, and we have group 1, 2, and 3, we have 3 groups which we have compared. So technically it will say that at least one group out of the 3 is different from the other one. It may be that group 1 is different from group 3 and group 1 is not different from group 2. It may be that group 1 is different from group 3 but not different from group 2. So in that case also the F-test will be significant. So sometimes it is also necessary, if F-test is significant, to run post hoc analysis. However, we are running short of time, so we cannot go through the whole thing in detail, and I cannot show you the whole process. It will take more than like 10 to 15 hours to go through each and everything in detail. So post hoc analysis. In post hoc analysis, we can actually see whether G1 and G2 is different, and whether G1 and G3 is different or not, and whether G2 and G3 is different or not. So in post hoc analysis, each type of comparison is made. So only if F test is significant, we go for the post hoc analysis. And there are many details about post hoc analysis. There are more than 18 types of post hoc analysis which can be used. So however, we are not going into such details. Again, so these are some of the commonly used statistics. Then again, we have something called chi-square. So chi-square can be used in two ways, that is test of association and the other is test of goodness of fit. So test of association is when we want to check whether two variables are related or not. Suppose whether gender is related with the smoking habits of a person or not. The smoking habits of a person or not. So the idea is that here both the variable for chi-square should be either it should be categorical in nature, right? It should be categorical in nature. It should be nominal in nature whenever we have to go for a chi-square test. And for these tests, obviously, it should be continuous. For these tests, it should be continuous. Okay. Further moving to, so we have two purpose for chi-square, that is test of association when we want to check when our variable is nominal and we want to check whether two variables are associated with each other or not, whether one has an effect over other or not. The other thing is goodness of fit. Goodness of fit is when we want to compare, we want to check whether whatever the observations we have, whether it is as per the expectations or not. There's a very classic example which most of us have studied in a bachelor. So which says that there is a dice with 6 sides and it is rolled for 60 times or 100 times, and the different faces appeared, for example 1, 2, 3, 4, 5 and 6. So these different faces appeared for different many of times, and then you have to calculate whether the dice was biased or not, so what we do, this is the observed value obviously, and this is then you calculate the expected value on the basis of the probability of each phase, that is 1 by 6, and then you check whether your observation and expectations are meeting or not. So don't worry, I have included all the analysis in detail in the material, so you can go through the material in detail, and there's a step-by-step process. I will show you my material here in 1 or 2 minutes. Okay, then we have correlation. So correlation is a test of association, whether two variables are associated or not. Okay, there can be two types of correlation. It can be parametric, non-parametric. Parametric is a Carl Pearson correlation is a parametric one, and a non-parametric one is your basically Spearman and Candle-Tau. Okay, so moving ahead. Okay, so coming to again correlation, we have two types of correlation. The one is parametric, Carl Pearson, and the again other one is Spearman and Candle-Tau. So depending upon the variable type, if it is continuous, then it should be Carl Pearson. Otherwise, it should be if it is ordinal, then it should be your Spearman-Lang correlation. Okay. Okay, so where we can find all these things in SPSS. So technically, we can one-way ANOVA can be used from this from here. So we go to analyze, we go to compare mean, we go to one-way ANOVA, right? We go to one-way ANOVA. So here we can include, for example, we can form variables on the basis of smoking habit. So whether weight, we have here three things like three types of smoking habit we can see in the variable 0, 1 and 2. So let's say 0 is people who don't smoke, 1 is some people who smoke for some times, and 2 is people who are chain smokers, right? So we selected the factor list as smoking, on the basis of which the analysis is going to run, and we selected the weight of a person, like whether the weight is going to vary or not. So we see we have different options here. So, and there's post hoc analysis. So this was I was talking about. There are more than 18 types of post hoc analysis, and then we have options. So in some types of the cases, so we can also run for the homogeneity of variance, and this is the non-parametric equivalent also for the ANOVA. So in case the options are not met, we go to these things. We go to the non-parametric equivalent, that is Welch and Brown false. Okay. However, uh, let's run and let me show you how it comes. So see, here we have a non-significant value of f test, right? Non-significant value of f test. The way to check the significance is same. If in the column of significance, if the value is less than 0.05, your f is significant. That means the weight differs in terms of smoking habits. But now we can say that irrespective of your smoking habits, your weight is not going to change. That is, your weight is not dependent on of the smoking habits. They are not related to each other, right? Smokers, random smokers and chain smokers have basically technically same weight. Again, we have correlation here. So we have bivariate correlation, partial and distances. Then we have something called regression. So whenever we want to find correlation, means whether two variables are associated with each other or not. Like if the one variable increases, the magnitude of one variable increases, whether the magnitude of other variable increases or not. If the increase is in the same direction or it is opposite to each other, whether each one increases and other decreases, or if you want to see the pattern in it, then or association in it, then we can go through correlation. So most of the correlation study is based on this only. Then we have regression. So regression analysis we have whenever we want to predict something, where we want to predict any future, right? So suppose we can say we want to predict uh, maybe the amount of crop which will be harvested on the basis of rainfall. So rainfall becomes the predictor, and amount of crop which will be harvested will become the variable which is going to be predicted. So if there is a single predictor, then it is known as simple regression. If there are more than one predictors, then it will be known as multiple regression. So however we can run it from here. So we go to analyze, we go to regression, we go to linear. So the dependent variable, if for example here we can say whether, let's say the dependent variable is weight. Let's say the dependent variable is weight, and let's click the independent variable is height. So whether we want to predict the weight of a person on the basis of height. So we know that as the height of the person increases, technically the weight of a person should also increase. This is a logic. Now with the help of regression, linear regression, there will be a model which will be plotted, and a model will try to successfully on the basis of predictor height try to analyze or try to predict the exact value of weight if height is known. Okay, so there are many details in it, like what are the different methods which we can use for regression, linear regression, and statistics. What are the different type of statistics, what are the meaning of these things, what are the assumptions of linear regression. So you have to go through all these things uh, before actually using linear regression. So I am just going through what is the purpose of use. Since we don't have much time now, it will take I think 2 to 4 minutes more. Okay. Okay, then we go to Then we have one more thing that is known as binary logistic regression. Binary logistic regression is used when a predictor, whenever the variable which I am going to predict, that is my dependent variable, it is categorical in nature. So these are some of the commonly used actually statistical methods when my dependent variable is categorical in nature, right? And similarly, the predictor can be categorical, the predictor can be continuous, but the dependent variable has to be categorical in nature. Further, moving ahead, there are some analysis known as cluster analysis, factor analysis, exploratory factor analysis that comes under advanced statistics. So for factor analysis, we try to group all the variables which are measuring the same thing. There are two types of factor analysis, EFA and CFA. For EFA, there are different methods, PCA, PAF. I'm not going into details. However, there are different methods. So the idea of factor analysis is to reduce the factors, or if variable 1, variable 2, variable 3, variable 4 is measuring the same thing, then what factor analysis try to do is they try to club it together into a single factor or component. Okay, so this is the idea of factor analysis. EFA is exploratory factor analysis. Whenever, if we are totally new to the concept, our research is exploratory in nature, then we go for exploratory factor analysis. If we are already aware of a model, or we are testing a model which has been developed in foreign, in India or in other country, then in that case CFA is used. Confirmatory factor analysis is used. So sometimes confirmatory factor analysis is also used with structural equational modeling. That can be done with the help of AMOS 2. Okay, then cluster analysis, like factor analysis tries to club the different variables together. In a similar way, cluster analysis tries to club the different cases together. So if we have different cases, case 1, case 2, case 3, case 4, okay, and if we can see that there is a similarity within these, there are similarity between these cases on the basis of the different variable which we have obtained, right? On the basis of the data on different variables which we have obtained. So cluster analysis tries to group all the cases into a similar cluster which are same. So it out of, for example, these are mainly used by marketing research. In marketing research, so if a brand wants to identify the different type of customers and what type of customers is using what type of services, for example, if there is a telecom company, and if the telecom company wants to identify who are the customers who are using data packs more, who are the customers who are uh, basically using data packs plus international calls, who are the customer who are using just basic services. So to analyze these type of things, to form clusters, basically cluster analysis is used to group all the people using all these using similar facilities in a same cluster, in a same group, in one group. Okay, then we have discriminant analysis. So see, logistic regression, discriminant analysis, and is basically is similar, shares a similarity. Okay, so the similarity is here. The similarity is here, the groups are known. Here the groups are known, group 1, group 2 is known. And now in discriminant analysis, now we try that on the basis of minimum how many variable, on the basis of minimum how many variable can we differentiate between the group. On the basis of minimum how many variables can we differentiate between two groups. Okay, so the purpose defines what type of analysis we are going to run. There is lot to learn in detail and a lot to know. It's a very huge topic. So technically we are ending on this note, and let me show you what I have attached. So just after the webinar, you will be receiving a mail where you will be having some of the data sample sets which I have used, and you can practice it and you can post your doubt. Basically, I've created a dedicated Facebook group. The link will be provided to you in the email. and you can post your doubt regarding the analysis there, and I'll be giving you the solutions, or what I'll be clarifying the doubts. Okay. And further, what is the thing which I have attached is a PDF of 57 pages, and it is a step-by-step PDF, and it shows everything how to what the column represents, basically whatever I have taught, and whatever there was time for and whatever there was not time for, everything has been included in this PDF. So if you just go through the PDF, and if you have any problem, you can just connect with me on Facebook group. Everything has been included in detail with dialog boxes and where to click, how to click, everything has been included here. Okay, so just go through the PDF, and so you'll be receiving this. Now I am unmuting all the participants. So if you have any query, so let's have a query session, question and answer session for 10 minutes, let's say, and you can ask me and I will answer as necessary. Okay, and then I am unmuting all of you. Okay. Yes, do you guys have any question? Hello? Really, I cannot hear you. Hello? If anyone has any question, just write in a group chat. Okay, I will see your question. I am waiting for any questions to pop up. If you guys have any question, just write your question in the chat. Yes, I can explain about linear regression, but I don't think it will be possible right now. So maybe in the upcoming webinar, or you may take a course with me. So I have also included a course here where if you go through the PDF, so you'll find it. So it's a basic and advanced statistic course. So depending upon your requirement, you can go and take this course with me. Okay. See, these things will take time, and it won't be done in a single day. Okay, no problem. Thanks for comprehensive session. Welcome. So we have our own data. How your guidance with data? How to get your guidance? You can contact me on the Facebook group. Okay, and then you can if you have any issue, or you have my number in the mail itself, you can call me whenever you like. Okay, single group experimental research. What's the question? Okay, someone asked me that he or she has a question with single group experimental research. How to conduct it? Okay, you want to know how to conduct a single group experimental research. Depending upon your depending upon what you want to find, depending upon what is the hypothesis, or depending on what is the research problem, you have to accurately think about the research design. It is not like that you select a research design first and then you want to conduct the experiment. Okay, so first you have to check what is your question, what is your research problem, and depending only if it is fit for your research problem, then only you should go for one sample research study. Okay, and Aparna, if you have any problem, okay, if you have any further problem, probably we can you can ask me later on over call, or you can ask me in the Facebook group. I will be replying to it. Okay, with the steps. Okay, binary regression, explain please. See, binary regression. binary or logistic regression, we try to, for example, let us consider that how Google knows which email is a spam and which email is a social promotion, which is a social, and which is a primary. So if you see, Gmail has three sections, right? It has primary mails, it has a social promotion, and it has some social, and it has a social promotion, three sections in it. So how the Google defines that which is a promotion, which is a social mail, and which is a important or primary mail? So these things are done on the basis of linear regression, right? So technically, uh, Google checks all the data. Okay, let me show you one thing.
నాకు కేట క్వశ్చన్
So I'm opening my email ID just to show you how Google works on logistic regression. It's a model based on logistic regression, how it is prevalent.
சொல்லிட்டு நீ போட ஆன் பண்ணி விட, நான் வந்து குளிக்க வச்சிடுறேன். அவன் ஒரு மாதிரி டயர்டா இருக்கான்.
Okay, we see that we have three sections. One is primary, one is social, and one is promotional. So technically, most of the thing where our name is mentioned, like see, there is a Naukri alert that says MD Huzaifa Arshad, right? So most of the mails where our names are used, so it is categorized as primaries in primary section. So what Google does, Google checks the mail content of the mail for name and important things. Okay, if we something write like urgent, if we use the some keywords like important, urgent, and name of the person, then obviously the mail is going to be logged in the primary section. So what Google does is, on the basis of different variables, on the basis of different keywords, Google tries to categorize the mails in primary, social, and promotional section of one's email ID. Okay, so it's a use of, you can say, logistic regression, where we on the basis of some data, on the basis of some variables, we try to categorize whether a person is going to donate or not. Okay, so donate or not. So there are two categories: either a person will donate or the person won't donate. That is dependent upon two things, we can say. The first thing can be that whether the person is humble or not, whether the person can feel the pain of others or not. Okay, and the second may be whether the person has the amount money with himself or not. So these are the two things. So one is a continuous variable, money is a continuous variable, and then the other variable, that is your uh, whether the person is humble or not. It can be expressed in continuous, or it can be expressed in both categorical too. So in that case, I want to predict whether the donation habit of a person, whether a person is going to predict or not, donate or not, on the basis of my variable income, and whether the person is humble, or he or she can feel the pain of others or not. Okay. So these two variables, on the basis of these two variables, I am going to predict a categorical variable. So that's the use of binary logistic regression. Technically, it's not possible for me to show you the whole process. Okay. Hello. Okay, then bye all of you, and probably we can connect on Facebook. Okay. Thank you. We'll get the recorded section too, along with your certificate.
Very good. ये अच्छा तो मैं पढ़ सकता हूँ.